Hello everyone, this is Somit. I have Saurav and Somadip with me today, and today we are going to show you a multi-step reasoning agent. In IT industry, choosing the right tech stack over various financial factors has been a key point for a long time. To solve this problem, we bring you Stratify AI. Stratify AI is a multi-step reasoning agent which takes users' input, retrieves important information from the existing knowledge sources, then performs guardrail validation, and finally generates a comprehensive summary between the tech stack versus the financial aspects. In this demo, first we will go to Somadip, who will be showing us the overall architecture of the application. Then we will move on to Saurav, who will be showing us a live demo. And then we will circle back to me, where we will do a little bit of code work throughout the backend applications. With that being said, I hand it over to you, Somadip.
Okay, so I'll quickly walk through the architecture about our Stratify AI agent. Let me share my screen. Let me know if you can see the architecture diagram.
Yes, we can.
Okay, so the core purpose of our Stratify AI agent is pretty simple. One, user questions. We generate both a technology feasibility view and a financial impact view, and then return a grounded recommendation with the citations. At a high level, user interacts with Copilot Studio, which acts as an orchestrator. When a question comes in, the orchestration layer decomposes it into two domain-specific prompts. One is tech prompt and another is finance prompt. Then these prompts are sent through Power Automate flows, which will call a FastAPI retrieval endpoint. On the back end, we use a RAG pipeline built on Azure AI services. Documents are ingested from Azure Blob, parsed using Azure Document Intelligence Services, which will have a pre-built layout. Then we have chunking, we have embedding, and we have indexed those into Azure AI Search. At query time, the retrieval runs as a hybrid search approach, combining both vector and semantic retrieval. Then those selected chunks are passed to Azure OpenAI to generate the answers. After generating the answers, we have a reasoning-based guardrail validator, which breaks output into corresponding answers, which also checks each answer against retrieves evidence. And then those API returns three structures elements, one with answer, citations, and guardrail metadata, which consists of verdict, we have a confidence, and if there is some issues or not. So the contract is what Copilot uses to render adaptive card sections for technical and financial analysis. So the structure is pretty simple. It's kind of a modular. We have an ingestion API, which handles all the indexing and document processing. We have our retrieval, which handles runtime question and answer for both the domains, and Copilot and the flows remains decoupled from the backend, which will have a JSON API as a contract. Having said that, I'll hand over to Saurav, who can give you a demo of the entire Stratify AI agent.
Thank you, Somanik, for a very well architectural description. Let me share my screen so that I can walk you through the demo that we have worked on so far. So here we go. Here is our agent built on Copilot Studio. As the name is Stratify AI. Uh, Starting with, it greets you about its identity, like who it is and what it can do. As Shomajit and Somit already described, that this agent will take the user ask, and then it will break the user ask in a multiple prompts, in our case financial and technical. and then it will go through all those LLM APIs and all those stuff to bring the answer. So here you go. Let me just start. Here I have a question ready. Okay, while it process, let me just walk you through in the topics. So as we said, we have a topic called data orchestrator, right? Here it takes the user ask, and then it divided the prompts in technical as well as in financial. Okay. Then it goes to the API to retrieve the data from the backend, that is our Azure AI Search, followed by OpenAI LLM, and then it display the data in adaptive card format. Okay, here you go. Keep in mind my screen is a little bit low resolution. Okay, let me just scroll up a bit. So here you go. The answer is well structured and now in presented to the user. We started with the technical analysis, followed by its summary, then proposed approach based on the user ask. It has structured the data in a well formatted manner, followed by key components or the basic things that are usually needed for our ask. And then at the end, you see we have a citation that supports this all the content. And if we hover on that, we see a URL as well. It now currently points to the blob storage that is Azure AI, sorry, Azure Search. But in real life, real-time scenario, it will point to the actual, the document location, be it a SharePoint or any other storage. Followed by that, we have this guardrail response validation, which Somadeep has just described. The verdict is partially grounded and confidence score also being shown to the user. Just following that technical analysis, we have financial analysis as the prompts are getting segregated in this too. It also includes this, all this content like cost drivers, licensing, procurement, effort, etc., etc. And it also supports, it also supported with that citation URL followed by the response validation results and wording. Being said that, I would hand over to Somit for a little bit of technical description. Thank you.
Um, Thanks a lot, Saurav. Thank you so much for the demo. So let us do a little bit of code walkthrough. So I will quickly share my screen and then we will look into our VS Code. So as both of them have highlighted that we have two separate backend APIs, one for ingestion and one for retrieval. So first things, we will look into our ingestion endpoint. Ingestion, that's a FastAPI application. So if you are setting up this environment for the first time, you need to have the Azure AI Search set up right correctly with the proper metadata. Like what I mean to say is, if you have a search index, you need to have these columns, fields properly set up, semantic configuration properly set up, and vector profile properly set up, right? So what we can do is we have one endpoint called create index. If we provide the index name and if we call this endpoint from any local client like Postman, then with all the metadata, search index will be created, and it will be easier for us to proceed with the ingestion process. The ingestion process starts with the ingest endpoint. Once again, we can call it locally from any Postman client for our demo application. It will actually chunk everything from any sample blob storage like we have. And if you have the sample documents over here, it will chunk this and it will upload into Azure AI Search. So let us look at what these API do, and we will go through one by one. So first it will first get the content of the blob using our blob container. And once the content is received from the blob client, then it will start generating the chunking for that. We have several methods for doing the chunking of that. We are using document intelligence API to get the document content, whether it's a paragraph, table, other content are present. Once the content is analyzed, then we are using multiple document parsers for creating the chunks. If we have paragraph, we are considering that into proper text. If we are having tables, then we are extracting the tables based on the polygon or the B box or the span elements, and then we are sending those table elements into LLM, and we are generating a summary with dictionary type, JSON based dictionary type elements. And finally, when everything is generated, we have the whole text, then we are using LangChain to create the chunking. We have the default chunk size and the chunk overlap. So once the chunking is generated, now the next step is to generate the embedding. We already have an embedding model deployed in the Azure AI Foundry. So using that, we are creating the embeddings. And once the embedding is created, we are merging those embeddings into our original chunk objects. So that's how the chunking with the embeddings is ready. Once these array of objects are ready, then we have to upload the chunk into the Azure AI search index. If this is for the first time, we straight away upload the chunk in batches, or if it is already existing, then we delete the chunks from the Azure AI search and then we upload that. So that will be done using Azure AI search client object. So this is pretty much the ingestion process, and let's move on to our next application, next FastAPI endpoint, which is the retrieval. So this is what you have seen in the live demo where Copilot is actually hitting in this endpoint. So what it is doing is it is getting the prompt and the prompt type, where this is making the decision whether it's a technology prompt or a finance prompt. In the prompt.py, we have all the prompts available here. Based on the technology prompt and finance prompt, we are declaring how the prompt engineering should be. We are making it strict. So first things first, we will do a hybrid search against our Azure AI search index, whatever we have ingested, our existing knowledge sources. It will get the top 5 chunk based on the approximate nearest neighbor search. It will use both BM25 and HNSW algorithm. So once the chunks are retrieved, then the next step is we have to build our context. This step is important because after building the context, we will send this context to our OpenAI LLM so that it can generate a RAG-based answer. So once the context is ready, we call the LLM. OpenAI once again chat completion model is deployed in Azure AI Foundry. So using the chat completion endpoint, we are actually generating a RAG-based answer where we already have the context, prompt, and the prompt type sent as a parameter. So once the LLM generated answer is ready, then we have to provide the reasoning based step, what Somadip has already explained in the architecture diagram, that we need to do a guardrail validation because sometimes LLM may do hallucination as well. So we are checking this. Each and every, RAG based answer will be split into multiple atomic claims, and each and every atomic claims will be validated against the context received in this step. So based on that, we will perform multiple scoring system. We will calculate the confidence, we will calculate the verdict, and once everything is ready, then we will generate a structured JSON response and we will send it back to main.py, and this response is actually going to be sent to the Copilot, which you have already shown, that Saurav has already shown to you. So I will show you once again a pretty much a similar thing what Saurav has shown, that this kind of thing will be generated. So what it is actually doing, the structured output which has been sent from the back end to the front end. So Copilot will receive that, and in the adaptive card, it will get all the properties, and the RAG answer will be displayed over here in the first step. The second step, all the citations will be displayed, what the backend application has sent. This citation URL is at Azure Blob storage URL as of now, and as sort of highlighted, then in real-time scenario, it might be your SharePoint document library or ServiceNow or whatever your existing knowledge source is. The guardrail validation, whatever we have returned, will be displayed in this manner in the response validated validation result, whether the verdict is partially grounded, fully grounded, or not supported at all, and with the confidence score. That being said, this is the end-to-end demo of this application. I hope you have enjoyed this, and we would like to thank you for staying with us. Thanks a lot, everyone.